So now let's do a practice problem where it's a one mean z-test and we're given sample data. So an instructor believes that the average study hours for the statistics courses is no more than 5 hours. They survey 15 students and they get the following data. There is a known standard deviation of 2 hours. The population distribution is assumed to be normal. At the 0.1 level of significance, does the data support the claim that the average study hours for statistics is no more than 5 hours? All right, so what am I given? Well, I'm given a sample, and here's my sample. I'm going to highlight it in yellow. And if I count that up, it gives me the 15 students. So those 15 students that gave me data, their study hours, that's my sample size. So my sample size is 15. So let me make it a little bit smaller so you can see it on the page. Okay. So then it wants to know, let's see what else I have. I have a known standard deviation, and we've talked about that. So that really is another way to say population standard deviation. So I can go here and hit 2 hours. And the wonderful thing is because I have a population standard deviation, I know without a doubt this is a one mean z-test. So I'm going to answer this question with the population standard deviation is given. Yay. All right. So then I know I'm given a level of significance. So I'm just going to copy and paste that in here. And that was given to me. I don't have to convert it any. It was just given. And I'm just going to highlight it so I know that I've taken it into account. Now, population mean. Well, they want to test that this average study hours is no more than 5 hours. So that no more than 5 hours is 5 hours is my population mean. 5 hours. But they do not give me a sample mean, sample standard deviation. And why don't they do that? It's because I, have a set of data. I don't have the sample statistics. I have an actual set of data. So I need to put that in Minitab and I need to run my statistics. But before I do that, I need to come up with my hypothesis. And it says they believe no more. Okay. So a lot of people get stuck on the wording of this. There is a sheet under hypothesis testing that gives you all the scenarios and how to put stuff. So think about it this way. If I say I'm going to give you no more than $100 for getting all A's, so no more than $100, that means I might give you $100, but I'm not going to give you anything over $100. So that means I can give you equal to $100 or less than $100, but not over $100. So that means I'm going to have to use the less than and equal sign together. So I remember that the null hypothesis always has to have the equal sign in it. So I'm going to insert the mean sign here. And then I'm going to do the less than and equal sign together. Again, no more means that I'll give you up to an amount and less than that amount, but I will not go over that amount. So for the null, the mean is less than or equal to 5 hours. And to make my life easier, I'm just going to put this as the original claim since I already know that. Okay. What is the mathematical opposite for no more than? It's more than. So that is that. So I have my null and my alternative. So that means in my alternative, I'm going to have to put the greater than symbol. All right, so I'm going to keep going. And I think I have everything I need. So let's go to Minitab. And to save time, I've already put in the data. So I'm going to go to Stat, Basic Statistic, 1 Sample Z. This isn't summarized data. This is actual data. So I click on that. I click in the box again and I get the blinking cursor. So then I go over and click on hours and it populates for me. Again, my population standard deviation was 2. My hypothesized mean was 5. And for options, all right, remember my level of significance was 0.01. So that means the level of confidence is 99. Alternative, again, was greater than. And if you're not understanding that, run back the video that we just talked about, and I gave you an explanation of how we do that. So I hit OK. I hit OK. And look, I'm given a lot of information. I'm going to copy and paste it to the Word doc so I can look at it. So I was missing this, so I'm going to go back here and put that in here, right here, and we can talk about it in a second. And then I need the Z and the p-value, and that is given to me right here. Okay, so I'm going to copy it and put it in here for me to look at in just a minute. All right, so I forgot to get the sample mean. But if I look at the output, look what it gives me. That 5.400 is my sample mean, so I can put it there. Again, it's giving me descriptive statistics for the sample that I just put in. So there, I've answered everything A through I. So now I need to go do the last part, and I'm going to put this down here so I can see it easier. We'll come back up to it. Okay, so what's my Z value? My Z value, I'm going to highlight what it is 0.77. My P value is 0.219. So when I compare 0.219 to, remember, 0.01, again, if you're thrown because of the decimals where you got 0.219, add another 0. So I have 3 decimal places here and compare 3 decimal places here. I can do greater than, and then it is a fail to reject the null. Okay, so what does it mean if I fail to reject the null? I'm going to go back up to my hypothesis. It means that my null is true and my alternative is false. So that means, yeah, okay, so they do study no more than 5 hours. So then I'm going to go up here. Again, I'm being a little lazy. I'm going to copy this sentence, and I'm going to go down and I'm going to write it to conclude this. So at the 0.1 level of significance, which is good, I'm starting the problem with how I have it. The data does support the claim that the average study hours for their statistics courses is no more than 5 hours. Again, how did I do that? No more than was my null hypothesis. It was my original claim, and I found it was true because I failed to reject the null. And because I found it true, I'm really basically taking that null hypothesis and I'm concluding it in words instead of symbols. So at the 0.1 level of significance, the data does support the claim that the average study hours for statistics is no more than 5 hours.